Imagine stepping into a machine and emerging in ancient Rome, or jumping forward to the year 3025 to witness humanity colonizing Mars. Sounds like science fiction, right? But what if it's not? Time travel has been a staple of pop culture for decades, from Back to the Future and Doctor Who to Interstellar and Avengers Endgame. But behind the Hollywood spectacle lies a serious scientific question that physicists have been grappling with for over a century. Is time travel actually possible? In today's video, we're diving into the real science of time travel. From Einstein's elegant theories to quantum quirks and mind-bending wormholes, we'll explore what modern physics actually says about journeying through time and whether it's something our future selves might one day achieve. So buckle up, because this ride's about to bend space-time. Einstein's theories of special and general relativity revolutionized our understanding of time. In special relativity, time isn't a universal constant. It's relative, literally. The faster you move through space, the slower you move through time from the perspective of someone else. This is called time dilation. And it's not just theoretical, we've observed it. Astronauts aboard the International Space Station age just a tiny bit slower than we do on Earth because they're moving faster. GPS satellites even need to correct for this effect to remain accurate. So, in a way, time travel to the future is already happening. And in general relativity, Einstein showed that massive objects like planets and stars warp the fabric of space-time itself. The stronger the gravity, the slower time flows. If you were near a black hole, time for you would tick much slower than for someone far away. This is exactly what the movie Interstellar portrayed in the now famous "Hour on the Planet is 7 years elsewhere" scene. So we can move forward in time, either by going fast or hanging out in a strong gravitational field. But what about traveling to the past? That's where things get weird. If you've ever heard the term wormhole, you probably picture a sci-fi portal ripping open space. That's not too far off. A wormhole is a hypothetical tunnel that connects two distant points in space-time. Think of the universe as a sheet of paper. Fold the paper so 2 points touch, and poke a hole through. Bam, shortcut. Einstein and physicist Nathan Rosen first proposed the idea in 1935, calling it an Einstein-Rosen bridge. Later, physicist Kip Thorne and others speculated that if one end of a wormhole were accelerated to near light speed, or placed in a strong gravitational field, a time difference between the two ends would emerge. In theory, you could enter one end and exit the other at a different point in time. But there are a few problems. Wormholes are unstable. They collapse too quickly for anything to travel through them. You'd need something exotic like negative energy or exotic matter to hold one open. And exotic matter? We haven't found any. Yet. Still, many physicists believe wormholes are mathematically possible. Whether they're physically real, that's still up for debate. If general relativity cracks open the door to time travel, quantum mechanics throws a party in the hallway. In the strange world of quantum physics, particles can exist in multiple states at once. They can pop in and out of existence. Some theories even suggest closed time-like curves, essentially time loops, could form in certain conditions. In 2020, researchers at the University of Queensland simulated a quantum time travel scenario with photons. The results suggested that information could travel back in time without causing paradoxes. This brings us to the famous grandfather paradox. If you travel back in time and prevent your grandfather from meeting your grandmother, how are you born to go back in time in the first place? Quantum physics sidesteps this using something called the many worlds interpretation. Instead of creating paradoxes, your actions create new timelines. So, if you stop your grandparents from meeting, you still exist, but in a new branch of reality. Quantum physics doesn't rule out time travel. In fact, it might support it, just not in the way Hollywood imagines. Let's assume, for a second, that time travel is possible. What would that mean for humanity? We could go back and prevent wars, cure diseases before they emerge, or change the past for personal gain. Who decides what's right to change? Then there's the terrifying possibility of causal loops. You go back in time and give a scientist the formula for time travel, but they only developed it because you gave it to them. So, where did the idea actually come from? It's a chicken and egg problem that still has physicists scratching their heads. Time travel also forces us to rethink our concepts of fate, free will, and destiny. If the future already exists, can we change it? So is time travel real? We don't know. But the science says it's not entirely out of reach. Time travel to the future? That's already supported by relativity. We've seen small-scale versions of it in real life. Time travel to the past? Not forbidden by physics, but we've got zero evidence it's possible. We'd need breakthroughs in quantum gravity, exotic matter, or a unifying theory of everything. As our understanding of the universe deepens, what seems impossible today might become tomorrow's science. But what do you think? Would you travel to the past or the future? What moment in history, or in tomorrow, would you visit? And do you believe time travel should even be allowed? Let me know in the comments below. I'd love to hear your theories. And if you enjoyed this dive into the fourth dimension, don't forget to like, subscribe, and hit the bell so you don't miss the next mind-bending episode. Until next time, stay curious.